Hi, my name is Amelia Atwell, and I would like to thank you for listening to my poster on the impacts of agricultural intensity on total nutrients and sediments, a 3-year study of the Cache River watershed. To begin, agriculture is the leading cause of stream impairments in the United States and serves as one of the largest sources of nitrogen and phosphorus into streams. This can lead to streams draining agricultural lands with decreased bank stability, increased soil erosion and sedimentation, as well as excessive nutrients that can lead to eutrophication and algal blooms. All of these, alone or together, can lead to a reduction in water quality. My research is on the Cache River watershed, which is located here in Northeast Arkansas. It is a highly agricultural watershed with 8 out of the top 18 rice-growing counties in the entire United States being incorporated within it. It is also listed as impaired by the Arkansas Department of Environmental Quality for excessive nutrients, turbidity, and lead. The objective of my project was to assess sediment and nutrient contributions to the upper cache through weekly water quality measurements. And my hypothesis was that agricultural land use intensity will have an effect on the level of sedimentation and nutrients, and I predict that low intensity subwatersheds will have the lowest levels of turbidity and nutrients over the 3-year study. Subwatershed land use intensity was determined for 12 subwatersheds using USGS's National Land Cover Database satellite imagery, where I calculated the intensity by taking the agricultural land use upstream and dividing it by the total drainage area minus the non-agricultural area downstream. I then grouped the percentages into low, moderate, and moderate high intensities. Additionally, I looked at differences upstream and downstream of the main channel of the Cache River. For sediment nutrient analysis, I went out once a week from October 2017 to September 2020 and used the bucket method for water collection. I then took a subsample for total nutrient analysis on a Scalar Sands Plus flow-through analyzer following American Public Health Association protocols, and a sample back for turbidity analysis on a Hawk turbidimeter also following APHA protocols. Looking at turbidity of the land use intensities in main channel locations, the median turbidity for low and low moderate intensities were significantly different from each other, as well as other land use intensities in main channel locations. Over the course of 3 years, no intensity exceeded the average of 250 nephelometric turbidity units NTUs, which is set by the ADEQ. However, moderate, high, and both main channel locations did exceed this 250 NTU close to 25% of the time. This supports previous studies that indicate forested lands have approximately 30% less sediment than agricultural lands, and that increasing agricultural activity increases turbidity. With total nutrients, the low intensity was significantly lower than all other intensities in total phosphorus, while low moderate intensity was significantly greater than all other intensities in both total phosphorus and total nitrogen, in which it exceeded state standards for both. Total phosphorus state standards were also exceeded for all other intensities. So the exceedance of total nitrogen and total phosphorus in the low moderate intensity may have been driven by the site Big Creek Ditch, which is located in Jonesboro, because this particular site had 2 to 4 times higher total nitrogen and total phosphorus than any other sites. And when it's removed, total nitrogen actually fell within state standards. The near exceedance or exceedance of state standards in turbidity and total nutrients is alarming for aquatic fauna. Having excessive turbidity and or nutrients can negatively impact stream biota because it can lead to homogenization of substrates, reduction of oxygen in the waterways, and ultimately reduce taxon diversity. It is important to continue monitoring the Cache River watershed and to work to reduce the inputs of sediment and nutrient into the waterways. Future work within the watershed should include further investigation into problematic subwatersheds like Big Creek Ditch and East Slough. Big Creek Ditch should be investigated upstream and downstream of the current location to try to pinpoint any potential sources of nutrients, and East Slough should get additional monitoring as it exceeds state standards for turbidity. And with that, I would like to thank you for listening, as well as thank you to my funding sources, the ANRC and the Arkansas Game and Fish, as well as the Ecotox Research Facility students and staff.